Good day, fellow pupils. Today we're going to learn about biology. So we're going to specific start with vision. So, as you know, vision is a very important sense which we use to locate and also to see other things we see in the environment. For example, we use it to catch prey or to run away from a predator. Also, we have our eye, which is the main organ which we use to see, and also we have the use which we also need, for example, to see our food, which we also like prepare, or also to orientate us around the environment. Mostly vision is also there to let other sense involved. For example, when we see something, our hear, touch or smell could also come in handy to just explore what we see and just to get know to better what we are perceiving through the eye. Next, we're going to go further into the eye, and first I'm going to list all the all the parts of the eye. We have the aqueous humor, vitreous humor, sclerotic, we have the choroid, the yellow spot, blind spot, we have the optic nerve, we also have our ciliary muscles, the subspinaceous ligaments, the cornea, the conjunctiva, and we also have the retina. And now I think we're gonna go into them and see the functions. For example, the aqueous humor, it is the liquid which is in front of the eye, and I think behind it, which I didn't mention yet, is the iris. It is the color part in our eye, which is also there to for the sun, which we perceive. Also there's the pupil and the lens. So we have the function of the lens. It catches the light, and it also measures it where to put on the retina, so it goes through the lens onto the retina. And also the yellow spot, its function, it's the weakest part of the retina. It's also like the most damageable part. Then the blind spot, it is where the optic nerve and the retina are the point where we cannot see anything, which is then blind for us. The optic nerve, it's one of the very important functions which sends our visual information to the brain, so we can perceive it as something that we see. So we have also the function of the cornea. It is also where the light comes through from the conjunctiva. And the vitreous humor, it is a jelly-like substance which is in the eye, and it also supports the eye. Then the sclerotic is the outer layer, it's like the very outer part, and it is the one which is like the toughest and also keeps the eye safe from other bacteria or things which can go into the eye. And also we have the retina, which is very important, where we have our rods and cones, which are our organs which we use to perceive light as a color, which we use as cones. And when it's darker, like around evening, we also use our rods, which is where we just see the object, but we cannot see the color, since we need the light to see a color. And that is everything for the eye. Hello again. Now we're gonna go to the next part, which is our ear. It is a very important sense we use because we use it to perceive sounds and to hear many things. For example, when we hear something, it alerts us, for example, for a prey, predator, and many other uses. For example, when there's a prey, when we hear it in the bushes, for example, our sense of hear can let us know that there's something to eat. We can go and catch something. If there's a predator and we hear it, it's good because we can run away from it. It alerts us before our vision, for example, which I've talked about before. If we don't see the predator, for example, if it's above us or behind us, our sense of fear will catch it before we have to turn around and see it. So it is very good to act quickly and react also to what gives an action. Now we're going to go into the function of the ear. First I'm going to name all the parts. So we have the pinna, the outer auditory canal, then we have the eardrum, then we have the ossicles, the oval window, the cochlea, and last we have the auditory nerve. So the ear works in this way. We have vibrations or sound waves which go into the ear, so from the pinna into the outer auditory canal. Then it hits the eardrum. The eardrum starts to vibrate against the ossicles. The vibrations continue through the ossicles, and it goes through the oval window into the cochlea. So now that's the most important part. In the cochlea we have hair cells, which are used to see the frequency from the sound, which goes from 20,000 hertz, which is the very first bit of the cochlea, till the very last part in the cochlea, 20 hertz. And after that we have the auditory nerve, which is attached to the cochlea. The information goes from the cochlea into the auditory nerve to our brain. Our brain processes this information and turns it into a sound that we later hear. All this sounds very complicated and a long passage, but it actually all happens in a fraction of a second, which is happening all the time. Like our ears, even when we're not conscious about it, it hears every little thing which it can pick up. For example, when we're in a classroom, we hear a fly. We are not conscious about it, but we hear it. Or in our sleep, we're not conscious about it, but we still hear every single movement. That's why in the night time you can get awake by loud sounds, for example cars, or if something drops on the floor you will still hear it. And it's also very good because when you're not conscious and something would attack you, you would wake up quickly because you would hear it. So this is also very good. Now we're going to see how waves are very important in our measurement. So waves are measured in frequency and the unit are hertz. And this is very important because we're gonna use this unit and this part of calculating sound very often, and that was the part about hearing. Thank you very much. Hello, here we are for our sense of smell. Today we're gonna start with the nose, since we have a lot to learn about our sense of smell. Our sense of smell has various functions, which are, for example, to smell something burning, which will alert us that something is about to get rotten, which is bad. Also, we can smell poison, which will alert us to not eat something since we smell it. Also, our sense of smell, as it might, is not that important. We still know that our sense of smell kind of affect our sense of taste, since if you have a blocked nose you can't smell, which will leave you a worse sense of taste, but we're going to come back to that later. So first we're going to go into the nose. So now we first need to know which source it what does our nose react to. So we have chemicals in the air which are called odorants. These are the chemicals which go into our noses, and when it is in the specific part of the nose, it's getting the olfactory bulb has olfactory cells, which are then connected to the olfactory nerves, which sends this information to our brain, and we're going to perceive it as a smell. And also you should know that we have over 100 different types of olfactory cells which we use to smell things, and this is everything for smell. Greetings everybody. See, now we are high up where we can without disruption talk about our sense of touch, which we use every day. So firstly, we have a primary organ, which is skin. The skin is covering our whole body, so that the slightest part of our body can feel anything which it can perceive. So we have types of informations which the brain receives as stimuli. For example, we have sharp edges, and we have the pain, which we can perceive, and also we have our texture of pressure. So let's continue with the 3 layers of our skin. The first layer is called the epidermis. It is made of dead skin cells and it is waterproof. So it also has a protection from UV rays and can sense light touch. So now let's go into the epidermis. So as I said, it's made of dead skin cells, which means that the very outer cells are dead and don't function. It is waterproof. So now I'm going to explain why our skin is waterproof. Our skin has oil glands, which makes us waterproof. If we would not be waterproof, we would suck up so much water that our tissues would start to swell and we could die in a few years. So that's why we are waterproof and water cannot go through our skin. We have a protection from UV rays. Since UV rays are damageable to our skin, we have protection against it so we wouldn't cook. Also, we have a very good sense of touch because it can also sense light. So, the next layer is the dermis. In the dermis, which is the second layer, we have living skin cells and we have the sweat glands, oil glands, blood vessels and a variety of touch receptors. So, the living skin cells nourishes the epidermis, which is the higher layer, which is what we talked about, which are dead skin cells, and the sweat glands are our glands which we use to wash our skin off when we sweat. Also, it cools our body, and also our oil glands, which I said before, makes us waterproof. Then we have blood vessels, which carries the oxygen to our living cells, which are in our skin, and a variety of touch receptors. Next, we have a subcutaneous layer, which contains fat for insulation and protection, cushioning, which makes our skin very soft, and it contains connective tissues to stay attached to mucus underneath. So, from the dermis, as attached, we have a variety of touch receptors. Let's start with our favorite one, which is the mechanoreceptor. It detects the slightest vibrations and the texture of different objects, pressure against the skin, and skin stretching, which is also affecting the movement of hair. Which means that the lightest vibrations, when you see something vibrating, our skin can feel this, and it's going to continue this to our brain. Also, we have the movement of hairs, which is when wind, for example, goes against the hair. It moves the hair and we can feel it, for example, as a breeze. Then we also have the thermoreceptor. It detects hot and cold temperature changes, which means that our temperature receptors can detect cold and hot things very quickly. So, next we have our pain receptor. It detects stimuli that damage our skin. And the most important part of this is that the pain receptors are not sensed by the thermoreceptors. For example, extreme hot, which is above 45 degrees, extreme cold, which is below 5 degrees, chemicals which are corrosive like acid and alkaline, and extreme pressure or skin tearing. So let's go back to the temperatures. 45-degree temperature is what I mean as our body temperature, not our environmental temperature we see outside, and not, for example, 5 degrees, which is outside our body temperature. Normally, our body temperature is at around 37 degrees. If it is 45 degrees, it is very hot and will hurt. If it's below 5 degrees, it is very cold and we can get sick also very quickly. So next, here is a diagram about our skin, and there are different layers, the different functions, and I think that's about it. here we are where we can see biology and human construction together. We're gonna start now with our favorite sense, taste! Woo! Who loves to eat? I love to eat. It's very delicious, pleasuring, it's so good. Let's get into it. So, we have variety of steps in taste. First, our tongue is covered with bumps called papillae. Each papilla contains multiple taste buds. Taste buds are filled with gustatory cells, the cells that do the tasting. The tip of each gustatory cell produces through a pore on the surface of the tongue. Nerves carry signals from the gustatory cells to the brain. The tip of each gustatory cell is covered with an assortment of taste receptors, which can detect a wide variety of compounds. Stimulation of any of those receptors send a signal to the brain, for example, bitter. So, now let's continue with the parts for, For example, when we eat something sweet, it goes onto our taste buds, it goes then to the nerves, which carry the signals to the brain and delivers this taste as sweet. All this, of course, happens very fast. Now we're gonna go to the main parts. The sensory organ is our tongue. The type of stimulus is the chemicals in your mouth, which we use to taste things. Survival, for example, if you are on an island, let's say, where many things like to eat, let's say something is poisonous, you don't know, and luckily you have your taste. So, the sense of taste, if something is poisonous, most commonly it's gonna let you perceive it as bitter. So you will spit it out because you won't like it, which is very good. So if you don't have a sense of taste, you wouldn't recognize you poisoning yourself in a very bad way. So now, I think that's all we need to know about taste. Hello everybody! How is it up there? Today we're gonna go through our last sense, which is our balance, which we use to stand, sit, lay down. Everything we do is used in our sense of balance. For example, when you sit, and you also use your sense of balance to not go side to side. And now we're gonna go into the part, how do you know what's going on in your balance? So for our balance, we have semicircular canals in our ears, which have a fluid which will move in our heads, and then we can perceive it as a movement. So the movement happens like this, and the semicircular canals makes you conscious of the movement. In our semicircular canals, there are also here, which are our nerves, which send it to the brain and lets us detect this movement. And I think you should all enjoy your sense of balance when you do sports, when you try to do some weird acrobatic thing, and have fun with your sense of balance. This is the end of our first biology lesson. Hope you will learn something from it. See us next time.